Hello YouTubers, hello and welcome back. This has really come out nice. I mean, it doesn't look nice, but it's certainly going to be in one piece. So this is going to be our multimeter for doing our tests when we do the alignment. I've got some good and bad news coming up. The bad news is I'm on the sick. My big toe, the joint, is swollen up. The whole of that part of my foot is swollen up so much I can't get a shoe on. The good news is that means we've got time. We can do some more electronics. So that's a good thing and a bad thing in one. So what I've decided to do is we're going to have a look at this radio some more. I don't know how long I'm going to be off. I'm going to be off a while by the sounds of it. I don't know when this is going to go down, this swelling. Just one of them things, everybody. Just one of them things. Nothing you can do about it. Can't get a pair of shoes on. I can't drive. Simple as. So I'm going to put this back together. And then we're going to have a look at the radio. There's a scale. See where it says 15? 1.5 volts. Spot on. So all we need now is to use this on our radio. Now the other thing is now we've got to, I'm going to play around with the radio now. Everybody, I want to make use of this time while I'm on the sick. This is the good news, I can play on this radio. Now you never guess, I can't even get my shoe on without being in severe pain, and they want me to go in tomorrow. And I said, there's no way. I said, no way I can go in tomorrow. I said, I don't think I'll be any good to anybody tomorrow. I said, Saturday maybe. They're desperate. They just haven't got enough drivers. They're either on the sick or have left. You know, I tell you, I told you why I was depressed. How it is at work at the moment is absolutely terrible, really bad. Really bad at work at the moment. So, good news is that we can spend time on our radio, and that's what I'm going to do next. And see what we get up to. Right, come back to the bench. I want to spend some time on my radio. I didn't notice that before. The plastic's missing out of the side of that connection block. It doesn't matter. That's where the light bulb should be. We don't really need that now. So I'll put a connection block in to hold it safe. I've redone the wires because they were all falling apart. This is the danger of doing it this way. You've got to keep an eye on these wires. As soon as they start falling apart, do something about it. Right, okay, I've come back to the bench because I had 2 packages turn up today, and one of them was elastic bands. They weren't very expensive. Now there was an elastic band on this before, but in looking at it I realised that the band that was on it, which is blue, the same kind of size as one of these, was rotten. So I thought one day I would buy some elastic bands and put it back. But I've since been on eBay and I've looked all over for a spring. It attaches from here. You can see the lips. There's a lip top and bottom to here, keeping this over. And that's what the elastic band was doing. Now I've been all over eBay. Yes, they've got springs, but nothing like that. And I don't know where. I think that might be a copper spring. So I was wondering if I could coil some wire up on a former of some kind, and then heat it up and sling it in some water and maybe make a spring that way. I don't know. I've never made a spring before. So I thought, because I've got more of these multimeters, and there's this particular one is another version, but it's a modern version. I thought, well, I don't really like that. I've got two of these. I don't really like these at all. And this is the first time I pulled one apart, and I thought, maybe there might be a spring in here I can pinch. And this is what the front of it looks like. This one goes up to the maximum of DC and AC, 3000 volts. It does work. The last time I played around with it. But no, it's too modern to have what I wanted. It was wishful thinking, I suppose. So anyway, let's get back to our radio problem. Right, let's get back to where we were before we got distracted. Right, I turned this radio on yesterday and I was testing around this resistor, this R47, which is 1.35k. Now when the voltage was turned down to when the radio was working on VHF, at this point here we was getting 209 volts. I've got a tickle. Oh, why do we always get this when we start recording? DC, but when we turn the voltage up to full voltage, it went up to 288. Now across the top of here comes down off the top of it, so it goes across C66, which is to ground. Those big tin can that we restuffed. Comes down here and goes straight into, I've got this right, yeah, pin 9. It's pin 9 that's snapped off. Pin 9 is snapped off completely, and this resistor goes straight to that pin from on the chassis. So when you look at, it's the EI84 that's in here originally, but at the moment it's got the 6P15 because this is the Welsh radio valve that's in here. That's why I put the two numbers down. Now you notice there's no pin 1 at all anywhere, which means pin 1 is vacant, it's not being used. Now this is the resistor. Now when I tested it on the multimeter, it wasn't that far out. I can't remember exactly what it was, but it was, I think it was 1.34 or 33k, something like that. Well within tolerance, but what if the resistor is affected by the heat? I don't know, because this gets very warm, as it would do. It's a high wattage resistor. One of the disadvantages with this schematic is it doesn't tell you any of the wattages of the resistors anywhere. It just gives you resistor values and that's it. So I don't know what wattage this is. So I would probably go, if I was going to replace this, I'd go overkill and put a really big one in, just to be safe. But it measures good. So the plan is to put it back. So I'll just get a pointer and I'll show you. This is it here. There's the pin that's snapped off. Let's see if we can get a bit more light on the subject. There's the pin that's snapped off. This is the pin we're going to use. It's vacant. Now that resistor, light. That resistor goes from this terminal here and is now going to go down to this terminal here with this wire and that wire. So that's what I'm going to do. I'm just going to hook it onto that, but I need to clean that pin up. But it still leaves us with the problem. We still don't know why we are getting these symptoms that we are getting. So I'm just about to clean up, as we've made a lot of work for ourselves. You know, 1 step forward and 10 backwards sort of thing. And then we'll come back here and check all this. I mean, this is the rectifier valve here, valve 7. And this is the line in. Now remember, the line in, this shows it being connected to the 225 volt rail, or 225 volt winding on the transformer. We're not using that. We're using this 245, which is what it should have been connected to. That's what it was connected to. And one good thing with this radio, which I've noticed, is it's got a switch on the positive and the negative mains. I've not seen many radios, old radios like this, like that, mind. 2 switches. Yeah. So this is a well-made radio. I really like this radio. If I can just get the damn thing to play properly. So, once we're done, we will start poking around here and see what's going on. But we've got to fix all of that first. So I've got some alcohol ready. Just going to clean the pin best I can, and then testing wires to it. Loads of flux, and then we should be good to go. Right, I cleaned it up. The terminal on that pin 1 with this on a very slow speed with some alcohol, cleaned up lovely, and then I find a pointer. I've got all the wires in that we need on there, ready to take the solder. So I'll solder all of this, and then all I've got to do is to wrap a wire around the base of this resistor to this pin here, which is pin 7, is it? I forget now. Oh God, memory. I tell you, my memory's terrible. Which pin are we talking about? Pin 9, that's it. So then we run a jumper across to pin 9. That's the best we can do. Other than that, it's replace the socket or put a terminal block in. And that means running extra wires, and we'll see how we get on with this first. Right, hello there. I've been asked to give a bit more detail on this Avo multimeter. I've never actually used this particular one. There's many different versions of it, and they're all slightly different. And the way the battery compartments are done in the back are different, and the voltages are all different. Somebody asked, would it not be better to change the case? In my opinion, no, not really, because the cases are different. The general layout is the same, it's the battery compartment that's different. Anyway, just hold on a sec. Right, this one is the one with the spring missing on the cutout. Okay, this is an older version, this is a Series 7. I don't know much about all the things it does. We've got I can't even see that. These aren't, I don't think these are the high voltage, I don't know. Usually these top ones are high voltage, but like I say, I don't know much about it. This is the one that came in the leather case. You can do ohms, like all the meters. You can do AC, DC. The voltages are the same on both. I'm trying to get this so we can get it to a position where you can see it. Try to do this quickly. Voltages on this particular one is 10, 100, 400, 1000. That's it. It's available in DC and AC. There's a capacitance side. I mean, I know nothing much about this. There's capacitance on this side, and I think there's resistance on this side. I'm sorry lads, I don't know much about the meter, not this particular one. I've not really used it very much at all, but this is an older model. I'm sorry, I thought I could work it out, but I can't. But the voltages are 10, oh God, there we go, 10, 100, 400 and 1000, and I'm pretty sure the 1000 are off these two at the top here. Right, but this case is okay. but it's the battery compartment inside. The way they link up is different. You can take the battery compartments apart, but I just decided it was better to repair the case. Now this one, is the next series up from this one. This is the one I'm planning on using. This has better scales and better things. It's 2.5 volts, 10, 25, 100, 250, 1000 DC and AC. You've also got your ohms. You would select it to ohms, which is that one there, and use the ohms on this side. Also, you can do milliamps. If you set this side here to milliamps, that's milliamps there. That's 100 milliamps, 1 amp, 2.5 amp, 10 amp. The ohms range is in this side, as it says there. But as I say, I'm not experienced at using these meters. I've never really used them. I've just got them on eBay, and I've always wanted one. I've got quite a few now. I've always wanted an Avometer, and this was the one that the teacher I told you about many moons ago used. And this one goes up to 2500 volts DC and AC. You've got a reverse button. You can zero the ohms, the ohms 100 and the ohms 100k. That's for zeroing the needle. But like I say, I'm not familiar with all the functions on these meters. I've just never ever really used them. This one doesn't do capacitance, where this one does. They're both good meters. The one thing that suffered the most is the leads. So Doug wanted some more information on these. This is the ranges. And this is the meter I'm planning on using. This is the one with the broken case. I mean, it's repaired remarkably well. The only thing I have to do to it really is to level off that side, the lip that meets the front panel, and tidy up this side piece here. Just use fillers. I'm not really bothered, to be honest. I'm planning on using it as is. It's not going to break it anymore. They work okay. It's just on this one we had trouble with that one. I thought we had trouble with the same on this one. This is a Mark 8. Oh, this is an 8 Mark II or something. It's got on there 8 Mark II. But they're all different versions of this. So I hope that was some help for you, Doug. And these are Bakelite cases. You know, they were the bees, knees, dogs, bollocks in those days, but I don't know what these are. But I presume that's resistance. I don't know what P and Q stand for. But that there is capacitance range, where my thumb is. But a lot of these I just don't know. I really don't know. So you would set that to capacitance, and then you would use one of these sets of scales. I hope that's a help to you, Doug. As I say, I'm not 100% familiar with these meters. I picked this one because it goes down to 2.5 volt, which is why I was using the battery to test it to see what the scales were. See, this one only moved up a little bit. It's 1 volt. I think it's 1 volt, 10 volt. think it was 1 volt, 10 volt, 100, 400,000. I think that's what it was. And it's the same, you can either do DC or AC. Alright, this is just an add-on because I've been doing some work on the radio, so I'll add this onto the beginning of the video that we're doing, and then the other part with me working on the radio, because I'm running into a bit of trouble. So I'm going to go back in the other room now and watch the remains of Riddick. Okay, thanks, catch you later.